Thank you. Hi, everyone. I'm Vlad, and I'm building a platform called Voxos. And the main point of all of this is that I try to concentrate on the problems that arise with Erlang and operations. Because operations is mainly the place where stuff breaks, no matter how smart your program is. And while you're prototyping, you don't care very much about ops. You just run an Erlang on your MacBook, and it's OK to prototype a program. And once you have to deploy your software, you have to think about some configurations, infrastructure layouts, and stuff like that. And once your system is big enough, it's always the case when the configuration of the infrastructure is like a part of your system. And if some problem happens, you can just take something in particular from your running system into a testing environment and just try to replicate the bug. So in this platform, I try to concentrate on this kind of problems where the development and production has to be homoiconic, like there should be no disparities between the development and production environment. And anyway, I concentrate in clouds, meaning that you don't always think that you have machines. You have some instances that compute some things. And when you write a program for the cloud, you have always take it into account that these are not the same environments. You can run one instance of your application on a 0 or on a million machines at the same time, or you can run 2 instances of your application on the same host, and you should be aware of that. And to facilitate that, we use Docker, well, for some things, and we are early adopting Erlang on Zen, which is currently in heavy development. So, as you already know, there are too many existing platforms that do their job very well. And there's no need to copy existing ones because, well, there's a lot of room for research, and you can always just try to pursue new things and see how it works. And the most problem with current platforms that you can use is that they try to make your application seem to look like it's the only one application running on the whole system. And this is like the fallacy that's enforced by the virtual memory pattern in current operating system and computing. It makes a process think that it is the only process in the system and has like a system call interface. Well, I'm trying to overcome that. So given all that, I'll try to reimagine the way how would a platform of my choice would look like. So currently, I'm trying to concentrate on rapidly prototyping new apps or just pull in existing apps and just make them run into some infrastructure as quickly as possible, or like being agile, like your managers like to call it. So basically, you have to do hacking, deploying, and then scaling. And life is too short to think about running Unix commands that try to copy files into the right position. And there are a lot more interesting stuff like algorithms and distributed systems that you have to care about. So I want to build apps, not just build infrastructures. And when I want to hack quickly. I want to hack reproducibly, meaning I have to be able to wrap up my whole application and just give it to some other person, and he would be able to run it in the same environment that you anticipated it to run in. For example, my colleague Max posted an announcement of a Skyline application to Erlang questions mailing list, and it's a simple web application that uses N2O and features authentication with different providers like Facebook, GitHub, and others. And Joe Armstrong actually took interest in it, and he downloaded that app. And the problem is that app used Node.js and used some Node.js scripts to compile CSS stuff. And we spent like 2 days explaining how to install Node and what version of Bash to use to run this app. And this is a stupid thing to do. You could have just given a single binary or a single file system image to some developer, and you will be sure that the app will run. This is like it was done 20 years ago when you would redistribute a single application image as a single executable file and it will just run. This is like you get an application on your mobile device You just download it from App Store and it runs. You just don't have to care about installing a database or writing configuration files, stuff like that. And when you hack, you don't want to have no frictions. For example, the main problem is that you don't write CGI scripts, but you write clever Erlang code that runs in a virtual machine and is compiled into bytecode. And you basically, this comes down to a problem when you have to dynamically recompile your code and then plug it into a VM. And when you hack and then wrap up your code, you have all these excuses that it works in my machine, and then you waste people's time trying to fix things when you're working in a production environment. And that's why you have to have your environment as close to production as possible. Well, for example, most of you develop applications on MacBooks, and when you write ports or NIFs, you use EPOL and Linux, and you use KQ, and you have mismatches between these two environments. When you write applications that rely on file system events, you have iNotify on Linux or FA-Notify, and they both are very poor interfaces, and you can use FS events in the Mac. And again, you have these disparities. Or when you try to deploy to CentOS, you have R14, and this is like mammoth crap, and you just don't, you have to rewrite the whole application. Or you just can't compile the port app from a Mac OS 10 because it's a Metro binary and doesn't use the same interfaces in Linux, and just copy it. So then you have to deploy. And if you have more than one command to deploy, you're busted because you will waste a lot of time trying to deploy stuff. And if you're working with production, you have a whole set of commands that you have to ensure that the deploy is fast. You will take shortcuts. If you can take shortcuts, you certainly will. Meaning, for example, if you have a single Beam module and it's faster to just replace the Beam module in place and then reload it, you will do that, no matter how your versioning scheme works, how your deployment is handled by the operations, and so on. So, and if you forget to do something, you will break production if you just replace a single Beam module. So you don't have to have moving parts. And by moving parts, firstly, I mean third-party software, like an operating system. You always have to take care of an operating system. You have to take care of a runtime. You have always to figure out that you run the correct Erlang version. You have to have all those libraries. And when you adopt some library or some application like Redis, which is a key value store, to your environment, it means that you become a maintainer. It means like you adopt it like your own child, because now you inherit all its bugs, and you have to take care of it. And meaning if you have to adopt them, you have to isolate their breakage as much as possible, because Redis breaking doesn't mean you have to have your Erlang VM broken. And also you have state, meaning some configuration files and resource files like images or whatever. And basically, that configuration disrupts your productivity because you have to take care about it. And operations is like about side effects in functional programming, because all you care about your functions, and operations just take care of anything else, and you have to anticipate it. And basically, deploying means mutating state. If the state of your whole system is just like a variable, you change it by issuing a deploy command. And when you use Linux, you have too many abstractions not on top of that, but probably beyond that, like users, access control list, CLinux. I'm sure anyone who uses CLinux just turns it off. Well, who doesn't use it just turns it off once he gets into his system. A networking stack, package managers. I guess most of people just try to avoid using package managers and just copy files into the file system. And even file systems. Many of you don't need file systems at all, but you all use it as given because they just exist. And perhaps you just need a simple level DB that's laid out on your disk. And so basically, this is a list of features that nobody needs when they write an application. And for some reason, a lot of development time is spent on overcoming the problems that are arising because of you have these implicit features in your environment. And I guess this is an example like you've always seen a lot of times on your CentOS machines. And this is probably something you would like to avoid. And when you use package managers, for example, you have this problem of half deploys. For example, if you write a post-install script that updates your environment and you screw it up, during an upgrade, when you have multiple packages like that, you have a broken system if one of these scripts fails, because your system isn't in any of these states that you anticipated it to be. For example, you can't just roll back to a previous working release because your system doesn't support it. And even Chief and Puppet is basically a thing that is prone to the same errors because they're simply frameworks that let you mutate some state. And this is like an example of apt-get failing to install a kernel, and this means that you will have a broken kernel once you reboot. So some hackers try to break abstractions by moving some implementations of some systems into user space. So like netmap, like accessing disks through a block device interface, bypassing the file system altogether, virtualization drivers that let you not buffer stuff multiple times, and which you don't need to do. And when you scale, the most platforms anticipate that you have like a worker style of scaling that you can spawn multiple instances of something, but it doesn't always work, depending on the way how your application is laid out or written. And probably you want to be distributed by default, meaning you want to use Ria Core and make sure that your deployment platform is aware of that, or use Raft, or even have an OTP for clouds. Well, you have OTP that lets you manage processes in a virtual machine, but why don't you still have an OTP that lets you manage instances in your cloud environment? Because that's pretty much the same. It's just an only one higher level of levels. And the one thing that I'm trying to work is to have an OTP for clouds, basically instances. Well, I try not to call them nodes because nodes in like a known current Erlang abstraction, they just call them instances. So they're pretty much alike processes. And you can have a supervisor. So except that, I want to have topology awareness, meaning, I will explain it later, I would like to have hot migration, and I would like to scale automatically and have it at a cheap cost, meaning that you don't have to over-provision. So when I speak about topology awareness, is that I don't always know that the application that I run, if it runs on the same disk or on two different disks. For example, if I run RIAC and I have to know the right value set to 2, meaning I have 2 copies always reading to a disk. And if my cloud environment doesn't let me know if I'm writing on 2 disks or on 1, meaning that if the disk fails, I will lose my data altogether. And my algorithm didn't anticipate that. And if I have 2 nodes that do similar computations and they get preempted by the same scheduler on the same CPU core, I would have TLB shootdowns, and I would have to restore the cache again and again, and this is something I would like to avoid. And I would like to have hot migration, meaning that if this is actually an older technique, which is called double buffering. It was invented in Quake, and the reimagination of this technique is called RCU, which is used in the Linux kernel and patented by IBM. Which basically means that if you want to update some value, you create a new instance of that value and then just automatically, atomically swap pointers. And this is patented. And I would like to have the same in my cloud environment. I would just like to spawn a second instance of something that works, make it necessary migrations, and if it just works, I will just swap it and make all older instances tear down. Instant bursting means that once you once you need to have newer instances of something, you can just create them and spend not 10 minutes, but like a second for that, because 10 minutes, because you know that you have to wait 10 minutes until the node provisions. You have to, you will waste precious customers and deny service to them. And to avoid that, you have to over-provision, meaning that you have to overspend money. And probably if you're an early stage startup, you don't want to do that. And also, getting back to this problem of too many abstractions, you have that thing that if you have a database, your usual database consists of a query cache, a database B3, which basically works to lay out stuff on disk to have fast access time to it, and then you have a virtual machine that this all runs in, and then you have a VFS cache that's relied into your kernel that does the same thing, pretty much like a query cache, but in another level, a file system B3 again, and then you have a block cache, which all do multiple layers of caching that you don't need to have because you have a query cache. And as I noticed, these 3 layers are inside the OS kernel, and you can just remove them and have all of this running on bare hardware, and that's where Erlang Zen shines. So for those who don't know what this is, Erlang Zen is wow. It's a pretty cool technology. It doesn't have an operating system underlying it. It's a bare virtual machine. It doesn't have any SMP because pretty much SMP is just a root of all problems. You always have to think about schedulers and schedulers blocking each other, and here you don't have it at all. It boots in only 30 milliseconds, meaning that you don't have to over-provision, and you can create nodes instantly. It's fast. It beats Beam on some benchmarks. Well, not just some benchmarks, but the Beam test suite. And it pretty much enables you to have an elastic cloud. So comparing to a measurement of how long it takes to start a process on this MacBook, it's just one millisecond. And it's only 30 times faster than creating a node in the cloud, which is not something that you can afford. For example, if you run stuff on Amazon and you have to wait 10 minutes to provision a large instance of some cool bullshit. Right, so Erlang Zen is also, here's a demo that was presented by Erlang Zen author on Kiev of Prague. I'm from Kiev, and we have a functional programming community. So we have a message of Charles Ring of almost 8 million processes in 613 seconds, and those on 1,000 nodes, and meaning that those nodes didn't have to exist all at once because you can just have ephemeral services, meaning that once you need something, it will spawn up in ridiculously small amount of time, which is pretty cool. So Erlang Zen is basically a project around a virtual machine called Ling, Ling meaning 0 in Chinese. It has a free build service. It doesn't have an open source. It doesn't have a source that's available to everyone yet. The build service just does, what it does is just translates Beam files to Ling and optimizing them, and it gives you a simple kernel image that you can run on your Zen hypervisor or on Amazon if you wish. It's mostly R16. Well, mostly because there are too many hacks, like trying to fake that actually Ling is Unix, because pretty much Beam is used mostly on Unix machines. It's active development. If you find a bug, go there. It has a lot of goodies and has a lot of different decisions that you may find in operating systems, like it uses Plan 9 file system. This is for accessing external stuff, like other file systems in Linux, or accessing or providing interfaces like procfs or sysfs on Linux. It has GUFS for persistence, meaning it's not a real file system because it has a tree-like hierarchy, but it makes you allocate disks in 4 megabyte chunks, meaning that this is everything that you need to provision your level DBs or Hanoi DBs or whatever on your disks. It doesn't support NIFs because NIFs kill the scheduler, and you all know it, but still try to bite the cacti. It doesn't have a net kernel yet, well, it's a work in progress. Basically, perhaps the OTP like for clouds will be embedded into Link. It doesn't have SSL working pretty much because ASN .1 is implemented. BERT decoder is implemented as an if, but I have a patch pending, so it will be resolved soon. And it doesn't have Erlang tracing. It has its own way of tracing called link trace. It's not so mature as Erlang's one because it doesn't allow you to match stuff as nice as you can do it in Beam. It has its own profiler, and if you need to build debug versions that you can inspect with GDB, you can use this config option with the rebar plugin that builds images. So it doesn't have much documentation yet. Pretty much all of the things that I told you were either read from Erlang Zen website or verbally given to me by the author of it, who by the way actually you can talk to later, maybe tomorrow, I think. So I think most of this can be found on Twitter of the project, or probably will be documented better soon. Elixir works there. eJabRD works. Link, the open flow switch, works as well. I've seen it beating the crap out of Beam's implementation, well, Beam's image. But I guess you can hear about that not here. I've ported React Pipe 1.4. Basically, it runs just on the single node because there is no net kernel, and React needs net kernel. And N2O, the web framework, works there as well. Actually, the N2O samples include Zen configurations that you can just type rebar link build image and just have the image running on your local hypervisor, which just renders hello world pages and chats and whatever. We use a lot of shell scripts and a C program that uses libxl just to avoid operating system overhead again, to avoid the overhead of Linux on spawning instances, because you can spawn instances in 30 milliseconds using libxl, and if you use XAPI, you have to waste another 10 milliseconds for that. So this is like work in progress that should be on GitHub soon. If you just can't use plain Erlang Zen, or you miss ports in the traditional sense, you can just spawn an OCaml instance from the project called OpenMirage. You can do IPC with Unix using the Plan 9 protocol 9p. Or you can use Rump. Rump is a pretty cool project allowing you to have some components of a NetBSD kernel wrapped up into a single binary with some application, like Beam or MongoDB, God forbid. And wrap it up in a single image and run it in ring 0 on your hypervisor, which is a pretty cool research project done by NetBSD guys. And now containers. Containers is something that approximate the vision of having a single image deploys like you have in Erlang Zen. You can have them on Linux machines, and you can write prototypes with that. And using containers, we try to prototype link features on top of Beam and make sure they work with each other. So for containers, we use Docker. Docker is pretty cool and pretty hipster, and it's like everywhere. And by the way, Docker is written in Go, and probably the key feature of Go is that you can deploy a Go application as a single binary because it statically compiles into a single file, and it's pretty cool. And this is pretty much the reason why some systems guys choose Go, because they just can give you a file and it will run. But on the other hand, Haskell can also produce a single static binary, but it's not popular like Go, probably for some other reasons, not just static compilation. Right, so we also tried using zones and jails, but zones are pretty cool. They're actually the first container technology ever available, if I'm not mistaken. Jails, well, jails are on top of FreeBSD, and FreeBSD was used by WhatsApp, and they got bought for 19 billion, so I guess I should check it out. And NixOS. NixOS is actually a pretty cool technology that allows you to express the system using a functional language, well, a declarative functional language, and just have some interpreter solve your description of the system and figure out all the deployments, and you can have almost atomic rollbacks, atomic deploys, and whatnot. So we're not using NixOS, but I guess it's pretty fun, and it shares a lot of values with boxes. So containers allow you to separate code and data. Basically, you have a single image, and you just put it in place of the other one, and it uses the same data. It's pretty cool. You can have instant deploys, and you can have no configuration at all. You can just have some arguments or make your application pull required configs on demand. And to facilitate like functional data, we use DFS, which is a copy and write file system. It has snapshots, and pretty much snapshots is the reason why we use DFS. And it has also cheap volumes. You can have isolation on the file system layer, and you don't need to have a huge, ugly volume manager like a LVM. And we don't use BTRFS because it doesn't work for us. And so all this comes to a paradigm of Lambdobs, as I like to call it. I always love to use the half-life logo to explain that, because there is a lambda, meaning an anonymous function, and it's in a circle, meaning it's a closure, and it has a 2, meaning it's like a higher order function. So it's kind of pretty much useful to explain all functional things on this logo. So Lambdobs. Functional deploys, meaning it's easier to kill something and create something from scratch because it's understandable and it should be repeatable, than to just mutate some values and make sure a deploy succeeds. So it means you have single image deploys. It means your app defines resources that it needs to, like CPU, disks, and it always knows if it runs on different disks or if it's an SSD, and this is what you need in a cloud environment. Basically, you have that copy update switch, RCU thing, or double buffering, where you could just create a new one because it's so cheap. So you can just have tens of thousands of them, in theory. Well, basically, having things cheap makes you over-provision stuff without any regrets and financial losses, I guess. And where your code is configuration. Basically, you can specify the same configs in the same language that you write your app in. And it's distributed by default because you run it in the clouds and you use libraries that facilitate that, like React Core. And it's instrumented by default, but this is, I guess, this is a whole other topic for discussion, meaning that you can't just have a profiling version of your code in production, but your instrumentation technology should facilitate that, like dtrace does for Solaris, and it's a whole other front of work to discuss. And to do that, we use a lot of different tools that we wrote or that we replaced or that we use from other suppliers. And basically, we're making new tools by deleting code from existing tools, which is pretty fun. And like having our own continuous building system, which is pretty stupid, like this robot from the movie, from the cartoon. Most of the code will be available on GitHub, and some tools are available there on my own private GitHub. These are tools like Active, which is a replacement for Sync that doesn't hog your CPU. A Sync that is a module that reloads other modules in runtime. File system watches bindings for Docker, a flame graph profiler that uses Erlang trace, and other libraries that will be expressed in the other talk about N2O. So that's pretty much it. Stay tuned, and more other interesting stuff will be released on my GitHub. And thanks all for attention, and now ask your questions. Yes?
Yeah, first of all, I want to say thanks for the eFlame application. Tried it to profile stuff, it's pretty neat.
Oh.
Secondly, I was wondering, you mentioned having a lot of stuff duplicated between the OS and the Erlang VM in general. And I was wondering what made you choose a box in general to drop the OS rather than dropping the VM to keep the single abstraction, right?
Well, basically, the VM is the OS.
Yeah. I mean, was it a choice because you really, really wanted to focus on using Erlang first, or it's just like...
Yeah, I just wanted to use Erlang, right? So, well, I guess Erlang doesn't give you everything that you want, like static typing, that you have to have to use during your leisure because you just want to. And there's Open Mirage that does that. It's pretty cool. And I guess there's HAL-VM for Haskell, but it's rather dead than alive, unfortunately. But I guess the approach of having like rump kernels and integrating them with existing apps, or the app, this new technology called OSV, right, that builds has a Linux-compatible interface and that lets you like embed MongoDB into it. So this should be pretty useful too. Any other questions? Yeah.
Can you talk about some of your experience specifically with Erlang on Zen?
Well, I'm basically just porting stuff now. So I don't run anything in production because, well, I just can see the source code. I've only seen it through the shoulder of Maxim, who's developing it. So this is pretty much research for me now.
Maxim is here apparently, so
Has he arrived, right?
I've not seen him yet. He's coming.
Yeah, he told me he's coming tomorrow, I think, yeah. Or
I think today.
okay, cool. Okay, so I guess if there are no more questions, thank you all for attention and thank you all for coming and stay tuned.